start from the first lesson, topic 9, as I told you.
Mister? Mister, now what lessons are revised? 1 and 2 and 3 and...
I'll show you.
Only before we only took 2 pages or 3 like that.
Yes, this is only 4. So we have here many topics in your book. You will go for topic 9. That's it. That's our exam will be from topic 9. We have covered totally lesson 1, totally lesson 2, totally lesson 4, and a part of lesson 4 until electric motors.
Mister, can you just say something quick about the project?
No,
Mister,
not right now. No.
I send you
in
the
the end of the
project.
session.
In
the end. Yes, maybe you can text me in WhatsApp. But here we are only for revision, guys. So we have the project, as I told you, have to do it and submit it before the end of the quarter. And it's related or about magnetic levitation. Any device that is magnetic levitation, and you can go to YouTube and type magnetic levitation devices project or magnetic levitation projects, and you may see a lot of projects that you can just do something similar to it. So let's start.
Mister, I sent you in the project. Can you see it after the school?
Yes. This is the first lesson, topic 9. Topic 9, lesson 1. It talks about electric force, and these are the questions about it. Let's start. And let me pick someone to do the first.
Can you Mr. Ahmed Adil?
Yes, you can, Ahmed. Ahmed Adil, yes, go ahead. Here's the first question. Okay.
Mia is building a diorama showing parts of an atom. She wants to better understand the effects of electric forces. An atom is made of particles called protons, neutrons, and electrons. Which of the following best describes each particle? Okay. Protons are positive, neutrons are neutral, and electrons are negative.
So which of the following best describes each particle?
C.
Protons are positive, neutrons are neutral, and electrons are negative. Bravo, Alex. C is the right answer. Let's pick someone else. Hassan al-Bishr. Hassan al-Bishr.
Mister, put C because I want to take screenshot.
What?
No, Mister,
what?
go back. I want to take screenshot.
Oh.
Sure.
This one? This question?
But I can't. Question number 1.
That's it.
Okay.
Huh?
Okay, Mister, you can go now.
Okay. So Hassan al-Bishr is here. Hassan al-Bishr. Khalifa. Khalifa. Muhammad Hashim. Sufyan. كل دول غايبين.
Mr. Do we have a revision sheet for the science quiz?
You will have the videos or these questions that we finish.
Yeah, but do we have a revision?
Maybe you have quizzes. No, revision sheet.
Okay.
محمد علي رضا الهلال. محمد الهلال. محمد علي الهلال. All of these are absent.
Mr. What's the deadline for the project?
By the end of the quarter.
And Monday.
Before Monday, because I have to submit marks before this.
Mr.
So the next week.
Mr. I have a question. Can you send the project that we will do? Send how we do it in.
I did it before, Kazim. I will not do it again. I did it before several times. I said that you will go to YouTube, type if you want to see similar. The project is about magnetic levitation, like magnetic levitated train. You go to YouTube and type magnetic levitation projects, and you'll see a lot of this. I have done this before several times. Okay. So Muhammad Hilal, read this one.
Okay, Mia is building a diorama showing the part of an atom. She wants to better understand the effect of electric forces. An atom is made up of particles called protons, neutrons, and electrons.
Neutrons and electrons, yes. Choose the correct words to complete each sentence. Read the first one. You will solve only the first one. Muhammad.
Choose the correct word to complete the sentence. Mia learns the electric force are
Until here. Between particles like protons and electrons.
attractive.
Bravo, attractive. So this is the first one. Thank you, Muhammad. Rakan Ruweshid. I'm clicking randomly, just I'm choosing randomly.
Okay.
Rakan Ruweshid. Rakan.
Yes, mister.
Yes.
You said my name.
Who are you?
Ammar.
No, not yet, Ammar. Rakan Ruweshid. Okay, Rakan. Read the second sentence and answer it from here until here, Rakan.
Instead, did you say my name?
Wait until I finish the lesson and it's here. اللي بيتكلم مين؟
The electric.
I mean in the like attendance.
Wait, I will come back to you. Just ask me after the question. Rakan Ruweshid, read.
The electric force are
Between, this is the completion of the sentence of the question. Between particles like protons.
Like two protons. Repellent.
Electric force are
repellent.
Between like charges, like what? Like two protons, because the like charges repel each other. Thank you. Rakan Ruweshid. Let me just Mahmoud Meher Ghazala. Mahmoud Meher Ghazala. Mahmoud.
Mr. Ammar.
Ammar, yes, you can answer Ammar. Read the last question in Ammar. This
force can be expelled over a distance due to electric fields.
Electric field, because these are called non-contact forces. They have electric field, and that's why they can act over distances. Jason, the next one. Jason, think that I didn't answer. Okay, Jason, here's the question. Read this one, Jason.
Of layer builds a correct connecting a light bulb to a battery with wires, leaving a gap in one of the wires. He places several objects across the gap to close the loop. He wants to see which objects allow electric to flow and turn electricity to flow and turn on the light bulb. Why do some materials allow electricity to flow through while others do not?
This is a question. After all this scenario, you have this question. Why do some materials allow electricity to flow through while others do not? What is the right answer here?
C, mister.
C, electricity will flow and the electrons, if the electrons are bound tightly.
No.
To their atoms? Before you answer, you have to read all choices and then pick the right one. So do this, all of the question, read all of the answers. Read them loudly and loud.
D, Mister.
Yes, the answer is D. Read it.
Yes. Electricity will flow and electrons are bound loosely to their atoms in the material.
Bravo عليك. Electrons will flow
Because,
in.
Mister, I didn't read all of it, just the beginning.
Yes, you have to read all the choices and then pick the right one, the most appropriate one. Thank you, Jason. Let's move and go back to random. Lift. Hamoud.
Yes, ma'am.
Raise this question, Hamoud.
Built-in energy is the stored energy a system has to do an action such as when you lift a book over your hand right before you drop its potential energy has also existed between the charged particles. Which of the following is true about the potential energy between charged particles? Choose the two that apply.
This is a question. Which of the following is true about the potential energy between charged particles? So we are asking about the forces between, or the potential energy between charged particles, like this. Like this here. These are charged particles. They could be positive, or similar particles, similarly charged, or oppositely charged, like this one, positive and negative. And we want to know which sentence, what are the sentences here that are right. So choose, read all of them first, then choose.
Potential energy increase as like charge gets closer. B. Potential energy increase opposites energy gets closer. C. Potential energy remains the same between like charge as they move apart. Potential energy increase as any charge move closer together. E. Potential energy decrease because energy gets closer. Potential energy decrease as like charge gets closer together.
What's the right answer? We have to choose two. Choose two that apply.
F.
So you choose F. Read it.
Potential energy decrease as a like charge gets closer together.
Let's see it. Like charges get closer. Like charges like this one, when they get closer, what happened to the potential energy? Increase or decrease?
Decrease.
If you bring two similar charge like positive and positive closer together, potential energy would decrease?
Increase.
It would increase, not decrease, because you go against the natural force. I said potential energy increases if you go against the natural force, which means attraction or repulsion force. Those already are repelling each other, positive and positive, and you go against that. To do that, to get them closer, you need to put more energy into the system because they are repelling each other, and you go against that. So this means what? If you put more energy into the system, this means potential energy would what? Would increase. Would increase. The choice that you pick it up here, that your choice here, not increase but decrease. So this one's wrong.
D, Master. D.
Read it.
Potential energy increase as any charge move closer to them.
Potential energy increase as any charge move closer. So let me try this one. Let me pick these two and try to get them closer. They are positive and negative. They already attracting each other. So they don't need energy to get closer. They already get closer from their own selves. So what should we do? This potential energy would increase or decrease. Potential energy in this case would decrease because they are already attracting. You didn't go against the natural force. You go with the natural forces. which is attraction, and that will lead to decreasing. So we have here two charges getting closer and the potential energy decrease, not increasing. And this is opposite to what you chose here. Potential energy increases as any charges move closer. No, because I show you an example. Potential energy decreases. That's here. Decreases. Potential energy decreases as opposite charged particles get closer. Negative and positive get closer. Potential energy decreases. So this one also is false. You have one more chance. One more chance.
B.
B is also wrong. Potential energy increases as opposite charge get closer.
A.
لا خلاص, enough. For you is enough. I will pick someone else. You have to bear with me and see if you can predict the answer. Abdurrahman Al-Hajji. Abdurrahman.
Yes.
So what are the right? We have one. You will choose two answers here. Is that right? You will choose only one, Abdurrahman. Which one is right? Pick only one. So read, take your time, and then answer. That is the question. You will choose two. We don't need two. We need only one. The next one we'll do it another student.
E.
Potential energy decreases as opposite charges get closer. Potential energy decreases as opposite charges get closer. Yes, it's E. Let's do it. Opposite charges get closer. That's it. Opposite charges get closer and the potential energy decreases. We just explained it. Positive and negative, they are getting closer like this. So potential energy decreases because you go with, I said, potential energy decreases if you go with natural forces. And here natural forces are attractive force. They're attracting and you go with it the same direction. So potential energy will decrease. So that's one answer. E is one answer. Thank you, Abdurrahman. Let me pick another one to answer. Al-Fahd Ismail. Al-Fahd.
Yes, Mr.
Al-Fahd, Abdurrahman choose one here, which is E. What is the next one? Because we need two answers here. And the question is, that's it.
Oh, okay. Okay.
Take your time to answer.
C, Mr. Maybe.
Potential energy remains the same between like charges as they move apart. No. Same charges move apart. Something like this. Let me show it to you. If similar charges move apart and you go with the natural forces, they are repelling each other, and this is your force. It goes with the repulsive force. So potential energy will decrease if you go with the natural force. So you are moving them apart from each other, and that's matches with their repulsive force, and that will lead to decreasing natural force, decreasing potential energy. And this is not what is written here. C, potential energy remains the same. No, it does not remain the same. It decreases. So C is wrong. شباب انت عندك you have only one rule here and it's opposite. Potential energy increases if you go against the natural forces. I mean by natural forces, repulsive or attractive force, attraction or repulsion. So here is repulsive force. If you want to increase potential energy, go against the natural forces. Like this, go against it. And this will lead to increasing potential energy. If you want to decrease potential energy, go with natural forces. That same applies to this one, natural forces, but here we have a different natural forces. Natural forces already are attraction forces. I'll make it in blue, for example. This is attraction forces. If you go with it, it decreases. Potential energy decreases. If you go against it, potential energy increases, and the same rule applies. So this rule applies here and here. So what is the right answer?
Mr. Maybe F.
We said F is wrong. Someone chose F before.
Mr. Can I answer Ammar?
No, I pick someone new. So bear with me, if that's me, let me pick someone else. Ali Suhail Manna. Ali Suhail.
Yes, Mr.
Ali, what is the right answer here?
Which of the following is true about the potential energy between charged particles?
Yes.
Maybe it's C.
Also, we chose C before and it's wrong.
You chose C and E, right?
C is wrong.
Okay. D.
Also wrong. Let me pick someone else.
I didn't understand the question. What's the question?
Wait until we answer it and then we will understand it. Abdulaziz Sultan. Abdulaziz Sultan.
Sad, I'm here.
Okay, Abdulaziz, what is the right answer for this question, Abdulaziz?
Okay. Okay. Potential. I think, Mr. It's B.
طيب. It seems that most of you don't understand the question. I will explain it simply, more simpler than this, more simpler than this.
Mr. Can you answer me, okay?
Wait, just so I'll let you answer, but just 1 minute. Again, guys, this question is about potential energy and charged particles. You have one rule. I will summarize all this in one rule, only one rule. If you needed to put energy into the system to move it, potential energy increases. If you didn't need to, potential energy decreases. I'll say it again. If you needed to put more energy into the system, potential energy increases. If you need to put more energy into the system while you are moving it, potential energy increases. If you didn't need to, potential energy decreases. If you need to put energy, if you need to put more energy or energy into the system while you are moving it, potential energy would increase. هتزيد البوتنشال energy. تعالوا نطبق الكلام ده. We have a system here, and I want to move it in this direction, for example. Ask yourself a question. Do I need to put more energy into the system? They already are repelling each other. Do I need, huh?
No, we don't need, because
we don't need. Oh, bravo عليك. So potential energy is what? Decreasing. خلاص نمسحها ونعملها تاني نطبق قاعدة مرة تانية.
Yes, Mr. Now I can answer now, Abdulaziz.
Wait بقى, wait. If we try to get this closer together, do we need to put more energy into the system?
Yes.
Yes. So potential energy will what? Would increase. So you have to ask yourself a question. If you need to put more energy in the system while you're moving it, potential energy would increase. If you didn't, it decreases. مفيش حاجة تانية بقى. خلاص؟ طيب عبد العزيز سلطان.
Can I know?
Yes. What is the answer?
Okay, Mr.
Take your time.
Okay. D.
طيب, let's read it for us. You choose D. Read it.
Energy increase as any charge move closer together. No, no,
Any
no,
charge
not
move closer.
not any. It's I don't know.
So it's not any charges because you have, for example.
Mr. Can I answer, Ahmed Adil?
Yes, Ahmed Adil. Go ahead.
Mr. want to answer.
عمار استنى أحمد. ها؟
Mr.
Ammar.
Yes.
Wait, Ahmed. Ammar, what's the answer, Ammar?
It is A.
It is A. Ahmed Adil and Ammar both answered A, and A is the answer. Because like charges get closer. Like charges get closer. Let me show you. Like charges get closer. This one, like charges. And when they get closer, you need to put more energy into the system because they are repelling each other. If you need to put more energy into the system, potential energy would what? Would increase. And that's what's written here in A. Potential energy increases as like charges get closer. You will need to put more energy into the system. So what you have to do, you have to apply. For D, Abed Sultan, if you want to answer D, potential energy increases as any charges move closer together. I will show you example. These are two charges getting closer.
I think that it's like
Yes.
I think.
So this are any charges, positive and negative. When they get closer, you don't need to put more energy into the system because they already repelling each other. So potential energy here is decreasing, not increasing. So this one is wrong. The answer is A and E, guys. Last question. Let me take someone else who didn't answer with us. Hussein Al-Gambar.
Just in topic 9.
All this question, topic 9, lesson 1. Tomorrow we'll take lesson 2, and later we'll take lesson 3.
I say for you.
Oh, Mr. Later we'll take lesson 3. Tomorrow the last session.
The final quiz will be on topic 9. Just in topic 9.
Yes, just topic 9.
All topic 9. Lesson 1, 2, 3.
Yes. Hussein Al-Gambar. Hussein Salman Dawood Al-Gambar. Kazim.
Here.
Okay, Kazim. Read this question, Kazim.
Wait, Mr. Get close. Jelani and Mika are watching an approaching storm from their living room window. All of a sudden, they see a bright flash of lightning that is soon followed by a clap of thunder. What causes lightning? Describe each step involved in the forming of lightning, and give an example of a similar process from everyday life.
Yes, we want to answer the first question only. What causes lightning? Can you answer this? In your answer, you have to include this description. Describe each step involved in the forming of lightning. So you have to answer this question, describing the steps of forming lightning. That's lightning that we take it before. We won't describe what causes lightning.
I actually I know the electric current.
So what causes lightning? What makes lightning? What happens in the sky? Why it happens in the sky?
When I actually forgot. I don't. Mister, can you help me?
Yes, I can help you.
I forgot, Mister.
I will tell you the first step. The first step of lightning, we will do it. We'll describe the formation of lightning in steps. Step number 1, the friction between cold air and which is moving downward and hot air which is rising up within a cloud, and also the friction among clouds. This creates a particle on the cloud that is negatively charged in the bottom of the cloud, on the bottom, and other parts of the cloud that will be positively charged, which is the upper part of the cloud. This happens for each cloud. So this is step number 1, forming of negative charges and the positive charges on the clouds. What happens next?
Then then the negative charge fall down with the lightning.
So at some extent or some level, the accumulation of negative charge on the bottom of the cloud will be strong enough to start an electric discharge. So this is an important word, electric discharge. You have enough accumulation of negative charge that will discharge to the ground, which is positive ground, or will leap from one cloud to another cloud, from the negative part of the cloud to the positive upper part of another cloud, or will leap through the same cloud from the negative part to the positive part. All of these are paths for the lightning in the sky, between cloud and the ground, from cloud to cloud, or within the same cloud. So we can summarize the steps as follows. Number one, friction happens within a cloud and among clouds. Number two, formation of parts which is negatively charged on the bottom of the cloud and other parts that are positively charged on the top of the cloud. Part 3, at some extent, the negative charge will leap out or will discharge from the cloud to the ground or from the cloud to another cloud. So these are the steps of forming what? Of forming lightning in the sky.
Mister, I have a question.
Yes.
It's about the second step. Can
What
you
is
say
it? Second step of lightning?
Yeah. What happened? I didn't get it.
According to the friction, this friction creates parts with negative charge and parts of positive charge. Friction between cold air, and because cold air is moving down, it's heavier than hot air, and hot air is rising up. So this movement, and also cloud with another cloud, or friction among clouds, will create parts of negatively charged parts. The bottom of the cloud will be negatively charged, and the top of the cloud will be positively charged. So the last question. Give an example of similar process from everyday life. Who can answer this question? Who didn't answer with me? Malik. Malik. Nawaf. Nawaf. مفيش نواف. سالم عبد الله سالم. سالم عبد الله سالم. تركي ناصر. تركي الناصر. مش حد موجود ولا ايه؟ محمد بوصبيح. محمد زكي بوصبيح. محمد بوصبيح. طيب
احمد خلص الحصه.
وات؟
خلص الحصه وعندنا بعدها على طول حصه، يعني الحين بدأ. يعني
Okay, you can leave right now, guys. No problem. You can leave right now.